Okay, so still for chapter 9, the last problem, and yeah, someone asked me about the symmetry, to use the symmetry to prove the congruence. Actually, yeah, we can see if we don't like the symmetry, we can use the rigorously to prove they are congruent. And now let me to prove it here. Okay, I want to re-explanation, use the exact mathematics to prove it. So there are two approaches we can prove it. Okay, so the first approach, so we have a circle, then we have a center. Okay, so there is a square in the middle. Okay, so if we can see, okay, after rotation, right? So let's draw a center, draw a diameter of this. This is the diagonal of the square, and also this is the diameter of the square. I mean of the circle, right? So here is the center of the O. So after you rotating, right? So this point is getting rotating, for example, to this point, right? So that means this diagonal getting rotating to this diagonal. Okay, so let me use different color. So before is the black. Now this one rotating to the red, right? Okay, so you know this angle is theta, right? So this is the rotation center with the rotation, right? But you can also see there is, in order to from this line, the black line, right? This black line to the red line, there is also a reflection center. That's this one. Okay, so this is the method one. Okay, so the rotation is the center. You can see from this point to this point, there is also a reflection center, right? When you reflected it, it will also be here. So that means there is the point. Okay, the point will be land on the from here to here, this line will be the reflection line will be the perpendicular bisector of the chord here, right? So and it also make it that the angle is half and half, right? Okay, now let's see this point, okay? And you can see if this is the case, right? So then this one is after there is the angle of the theta, right? Then this one will be here. Okay, so you can see we can reflection this point to here, and this point to here, and this point to here. This is the reflection line, right? So here is the half of the angle, here is the half of the angle, right? So now you can see, okay, the crossing point of the center, okay, this doesn't change, will be also land on this one. So you can now we can use the this is the square root of the this is the radius, and this is the radius, right? Angle, and the common side. Okay, then you can see they will be congruent. This is the first way, is to use the reflection center. The second way, okay, the second way is to use the congruent triangles. This is the center, right? So we rotating to the angle of the alpha. I mean angle of the theta. Then this is the nu. Okay, so now let's see. We have a crossing point here. Okay, so what we want to prove is this triangle is congruent to this triangle, right? Now let's see, okay, how we can prove it. We from the center we notice that this chord is equal to this chord. Okay, the two green chord equals red chord, right? We can do we can from the center we can do the length of the perpendicular bisector to the chord. Okay, now what we know is from this one, what we know is the what we know is this one, right? Because the distance to the chord is the radius minus half of the half of the chord. The radius construct a right triangle. So that's why the radius is the same. The half of the chord is same. Then we have this one equals to this one. So for this small right triangle and for this right triangle, right, we have this one equal this one. This is the common side, so of course the other side is equal, right? You can use SSS to prove this triangle is congruent to this triangle, right? Then we can prove this side will be equal to this side. Okay, let's see, it's x and x. Okay, and you can see on this side is half of the chord, right? Yeah, it's half of the also the side. It's 2a minus x. That's this length. This length is also 2a minus x, right? So now you can see we want to prove this is the right triangle, angle is the same, right? So they are similar, and also we prove the and also we prove this one equals this one, right? So this is the half of the size minus x, and this is also half of the size minus x, right? So we have two similar triangle with the corresponding of the with the corresponding of the leg is the same. So of course they are still they are congruent. Okay, so that's it about re-explanation of the congruent. Thank you. Bye.